Proposition 88. When we toggle the assumption at the core foundation of almost all disciplines of science and relegate a finite universe to speculation and promote an eternally infinite universe to premise, then little by little we can see nearly all the current mysteries and paradoxes of science unravel ever so elegantly at our feet. Proposition 89. It was a mistake to assume we discovered anything elementary because it was a bold assumption to make in the first place that we are even capable of seeing anything elementary. Proposition 90. When we remove the assumption that our standard model of particles are elementary, then it becomes obvious how mass and energy below quantum scales would cause quantum weirdness to disappear in favor of classical relativistic physics. Proposition 91. We lack the scientific precision because the laws of physics dictate the limits of what we can see. But if that issue was removed, we would see there is a superdeterministic sequence of subquantum states that produce each quantized quantum state. Proposition 92. We would predict superposition, tunneling, and a probabilistic wave function if subquantum interactions we can't see were causing aggregations of random attractions and repulsions at subquantum scales to manifest as all the quantum fields of our standard model, and a reason why particles in motion randomly deviate from their predicted paths. Proposition 93. If there was a subquantum realm far smaller than the electron neutrino, in abundance far greater than neutrinos, it would explain vacuum energy, virtual particles, the need for renormalization, the reason for wave-particle duality, the reason for a probabilistic wave function, and a logical premise to explain how space-time can bend and warp in the presence of mass. Proposition 94. Finally admitting we were premature to claim we located anything elementary will pry open the doors previously shut by our presumptuous assumption. Aggregations of subquantum waves in phase can become virtual particles or vacuum energy, and if dense enough, then they become quantum particles. They would also be responsible for tiny repulsions and attractions we can't see, which is why we have superposition. Proposition 95. At the onset of quantum mechanics, an assumption was made that created a century of mysticism. We saw an interference pattern where we did not expect one that disappears upon closer inspection, and knew that at the core, a particle in motion moves as a wave. Yet we then question which slit the particle went through. A foolish question to ask in the first place, since if it were traveling as a particle, there would be no interference pattern at all. Proposition 96. The assumption was made that a wave of energy spreading out would not be able to manifest as a particle at the point it is needed. Yet that assumption could easily be wrong. Energy returned to the subquantum realm where not needed, and pulled from the subquantum realm where needed in order to abide by the laws of the conservation of energy and conservation of momentum, could explain how a particle in motion as an expanding wave of energy arrives at its destination intact as a particle. Proposition 97. We guessed what it meant for a particle to become a particle, and a century of mysticism with spooky action at a distance is what we have to show for it. A particle becomes a particle when the macro worlds of physics, electromagnetism, chemistry, biology, or thermodynamics, among other disciplines, dictates the need for a particle at a specific point in relative spacetime. Otherwise, like all other energy and motion in every other wave, it moves in all four dimensions of space-time. Proposition 98. Aggregations of tiny subquantum waves in phase would occasionally manifest at our quantum scale factors, and we see this as measurable vacuum energy. When the underlying density is sufficient, or the number of these subquantum waves in phase is large enough, then we see a particle in one of our quantum fields. What we call excitations in a quantum field are just aggregations of subquantum waves in phase, and stable ones become particles, while unstable ones are relegated to virtual particles and vacuum energy. Proposition 99. Aggregations of tiny subquantum waves in phase, not yet of an intensity to excite one of our quantum fields, could still cause subquantum attractions and repulsions that would be predicted to cause other waves of polarized energy and motion at our quantum scales to deviate from their predicted paths. A probabilistic wave function is a prediction of a subquantum realm. Superposition and tunneling are the repercussions of those subquantum interactions beyond our purview. Proposition 100. It is incorrect to believe that superposition means that a particle is in two places at the same time. A particle is not a particle until that energy in motion needs particle-like properties in order for the sciences of our macro world to function. Before then, it is not a particle in multiple spots, but an expanding wave of energy, flowing like every other wave, trying to explore all four dimensions.